So today I want to talk to you about this Element TV. It's a 40-inch LCD. Element, not a super big name brand, but yeah, it's a TV nevertheless. It's only a couple years old. April of 2010 is the date of manufacture. And so the problem that we're having with this one is just as soon as you apply power to it, you'll hear the relay over here click. We never get any LCD action, never get anything going on. So the first thing is to get down here and measure these voltages. It's not an exact one-to-one, but you can go by starting at the top. The first two pins should be ground, and then standby. That turns the power supply on and off, or it should on this one. The next two are 5 volts standby, so that's what we're really concerned about. And after that, it's 12 volts ground, and then the 5 volts M on the very end. So let's take a look at those and see what's there and what's not. So starting with the first two pins, I have my negative lead of the meter on the chassis ground, so any exposed metal. First two are ground. Third pin is labeled STB. I assume that's standby. That's the control for the power supply to turn it on and off. It's 2.1 volts, so it's enough to drive the transistor that turns on the relay. The next two are 5 volts standby. We've got 4.7 volts, so that's enough to activate the microprocessor to keep it active, just enough. If it was much lower than that, I would be concerned. What concerns me is the next two voltages are labeled as 12 volts, and as you can see, it's got 7/10 of a volt, 6/10. So let me put the meter on the min-max reading. The highest it goes is 1 volt, so that's a problem, and that's for the 12 volt source. After that, we've got labeled as ground, BR1, switch, SW, ground, and then 5 volts M, and they're both virtually 0 volts as well. So what we can do is go ahead and take a look at the power supply. What really concerns me is that 12 volt source that's just kind of sitting there and it's wavering just a little bit. So let's look at troubleshooting the power supply. Alright, so looking at the power supply board, I mean the first thing, as with most LCD or plasma TVs, is just visually take a look at the tops of the major large capacitors and just make sure they're not bulged. All these look perfect. Besides, with the manufacture date here of April 2010, it's at this point when I'm making the video, it's only 2.5 years old, so I would not expect any capacitor problems this early in life. So what I'm going to do is I'm just going to give you some tips with the power removed and this board out of the set. There are some diodes and FETs, field effect transistors, on the heatsink. So we can check those with an ohm meter and see if any of those are shorted or defective. So these that we're looking at right here are the rectifier diodes. Let's see if I can zoom out just a little bit. And they come out of the main switching transformer. They rectify the AC into DC. They're filtered by the capacitors, and then it goes out. So we can check those. Hard to show you, but I've got my meter in the diode position. I'll just zoom over here. It's in the diode position here. And so let me show you what you should have. Normally when you check a diode, black goes on the cathode, red goes on the anode. And so let me move the camera over here so you can see exactly what the meter's doing as I check it. So black on cathode, red on anode. And I see a reading, it charges up. Now I'm going to reverse the leads. I'm going to put the red on the cathode and the black on the anode. It should charge up and it should continue charging. And that tells me that the diode is good. The junction is good on the diode. So I'm going to check the other one the same way. Red on the cathode, that's the band. Black on the anode, which is the arrow portion of the diode. As you're looking, it continues charging up. So that one's good. There's one more here I'm going to check. It checks good. Now, on the diode scale on most multimeters, it shows you the forward voltage drop, 0.307 volts. So as I do it backwards, it should go to 0 and then start charging up. because it's reverse biasing the diode right now. So those diodes check good. So let's check the FETs, field effect transistors, as well as the power factor control circuitry. So I'm going to do the same thing. I'm going to leave my meter on the diode range. Before you start checking anything on the primary side, and that's the side with the AC transformer, let me see if I can stand up my meter where you can see it in the camera a little bit. Yeah, you can just see it. So I'm going to check the voltage on the main filter capacitor here. It's still got 65 volts on it, so I'm going to put a resistor across it to discharge it. Let's check the voltage across it now and see what it is. It's 1 volt. So we can go ahead and test the part safely on the other side now. Put my meter back in the diode range. So I'm going to test this diode right here. It tests just fine. I'm going to check these field effect transistors here. These are the output transistors that drive the transformer. And what I'm looking for is either a diode or an open. So there's the diode. That's open. And that's source to drain, so I'm going to check gate to source. It checks okay, no shorts. I'm going to check source to, or excuse me, gate to drain. Now on some of these you'll get a dead short because there's a low value resistor. This one checks okay. Do the same thing. Diode checks good there. Both the FETs checked fine. Now I'm just basically showing you this because I've already troubleshot this board. I know what's wrong with it. In fact, I have the new part to repair it. Technically, the way they couple the FET output to the transformer, this is the FET output right in here, and it's actually coupled through a capacitor. If you look on the other side of the board, it's this big blue capacitor right here, labeled C842, and the output transformer, switching transformer, is capacitively coupled to the common of the FET switching. So if you follow this, the positive from the filter capacitor goes to the source of one of the FETs. The drain of that source goes to the source of the second FET. The drain of that will actually couple through the capacitor to the transformer. Actually, the source of the drain of that FET the drain of that FET couples back to ground. And so what it's doing is one transistor couples the positive and charges the pulse positively into the transformer. The other one couples the negative charge and discharges it, and it causes a field, a magnetic field, to build and collapse, and that's what actually creates the voltage across the transformer. So, knowing that, I'm going to go ahead and replace this capacitor and show you what the measurements are. Now, you can always test your capacitor if you wanted to. On this meter, I've got it in the capacitance range now, just in case you don't have an ESR meter, an equivalent series resistance meter. So we can put our probes across there, and you can see it reads 1 nanofarad on the scale of the meter, which is bad because the capacitor value on this one is 47 nanofarads, and it reads 1 nanofarad. So here's the replacement capacitor, 0.047. So if you move the decimal point 3 places to the right, it changes it from micro to nanofarads, and 3 more places changes it to picofarad. So it would be a 47,000 picofarad capacitor. Measuring these on the voltmeter, it doesn't matter where your leads are, but as you can see, this one reads 50 nanofarads, or 0.047 microfarads. So this is the capacitor I've chosen to replace it with, and it's a metallized film capacitor. So let's go ahead and install that and see how it goes. So just out of curiosity, people will ask what capacitor I used in this. So here is the original part number from Mauser. Mouser.com, and if you need to, there is their actual phone number that you can get a hold of them directly and order these capacitors yourself. Alright, so here's my board with the replacement capacitor in it, so I'm going to go ahead and put it back in the set, and we'll fire it up. Alright, so here's my set again. I've got the board back in it and all connected. So I just wanted to show you the voltage measurements again. The first two were ground. The third was STB, that turns on the relay. The fourth is the 5-volt standby, which is now 4.9 volts. The fifth is the same. The sixth is the 12-volt source, 11.95, perfectly acceptable there. The next one's 12 volts as well. After that, we've got ground, BR1, that's got to do with the backlight, I'm sure. The next two is switch, 3 volts, that probably turns on it, and BR is probably the brightness range. Ground, ground, and then we've got 5 volt M is in mic, 5 volt M, and it's working. Now one thing I noticed that's different on this set now that it's operational, just as soon as I plug the cord into it, I get the click. And I get a second click a few seconds later because it's running a self-test, and now that it's passed the self-test, everything's okay. So now, with the remote, I turn the set on. This is where I was when I was showing you the voltages. So I'm going to throw the back on it, and we'll stand it up here and finish the video. So here's our set all up and going and running. Everything looks great now. What's interesting is I have another one exactly like it. It's the same exact model in here. Had the same exact problem. So I've got two of these sets currently in the shop at the same time with the exact same problem. Well, I hope you enjoyed this video, and I hope it definitely helps some people out on these sets. Keep some more sets out of the landfill or the recycle bin, as the case may be. I appreciate all your views, all you subscribers. Everybody have a great day, and thanks for watching.